range of sizes and finishes for outside and inside measurement, reading to thousandths and tenths of a thousand. Special micrometers with capacities up to 12 feet are practical and accurate with Starrett's new lightweight tubular frame. Micrometers designed for special purposes include the sheet metal micrometer with a deep U frame for gauging overfeeding or flanges or to check thickness at any point well in from the edge. Another is the screw thread micrometer with a pointed spindle and a V anvil which is used for measuring threads. Tube measuring micrometers are equipped with a special anvil for measuring tubular walls or the thickness from a hole to an edge. With a large disc on the spindle and a floating anvil, the paper gauge micrometer readily adjusts itself to soft surfaces. Depth micrometers afford accurate measurement of the depth of narrow slots, shoulders, or small holes. Measuring rods provide a range of measurement by thousandths from 0 to 3 inches or more. To some, a micrometer may look like a C-clamp, but when we see all the parts laid out, it begins to look like quite a complicated device. The anvil and spindle are hardened, ground, and lapped. The faces are lapped to a high micro or mirror-like finish. The spindle threads are hardened and precision ground from the solid and stabilized for a long life of accurate measurement. The graduations are sharply cut and the numbers are easily read, and a certain chrome finish prevents glaring reflections. When a measurement has been taken, a knurled locking nut locks the spindle firmly, making it a solid gauge if desired. All good mechanics clean and check their micrometers frequently. A piece of paper will remove oil and grit that may cause inaccurate readings. Close the anvil and spindle faces with normal feel and check the zero setting. If necessary, rotate the sleeve with the small wrench included with all Starrett micrometers. Check again to be certain that the zero graduation lines up when the anvil and spindle faces are closed under the tension you normally apply. This inside micrometer caliper uses the same screw principle. The distance between contacts is changed by rotating the thimble on the micrometer head. Extension rods may be placed at either end to increase its measuring capacity. Inside micrometers are often used for measuring the inside diameter of cylinders. Practice and caution are needed to obtain the right feel to ensure correct measurement. Hold one contact point in a fixed position and rock the other to be sure the tool is spanning the true diameter of the hole or correct width of the slot. Another instrument for precision measuring is the dial indicator or dial gauge. It is extremely useful for setup work and saves valuable time in inspection where large numbers of duplicate parts must be checked to close limits. Built to fine watchmaking standards, its carefully finished gears, pinions, and other working parts result in measurements accurate to a tenth of a thousand. Contact points may be replaced with special anvil units of almost any shape or length. A special Starrett shock-absorbing anvil unit, which will fit any make of dial indicator built to American gauge design standards, is a wise precaution whenever an indicator is subjected to severe usage or shock. The contact point is attached to a rack which projects from the case. Movement of the rack is transmitted to a pinion, then through a train of gears to a hand on the face of the indicator. When the hand of the indicator makes several complete revolutions in covering the range of the instrument, a small revolution counting hand is provided to indicate the number of revolutions of the main hand. The dials are calibrated in a variety of ways for direct or continuous reading or to indicate plus or minus measurements. When dial indicators are used for the inspection of a number of similar pieces, tolerance hands can be quickly set to show allowable variations of the pieces. A dial test indicator combination is particularly useful when comparing measurements obtained from gauge blocks to a workpiece. Machinists find the dial indicator a useful tool for comparing measurements right on the machine. On this milling machine, a dial test indicator combination used with a gauge block shows the operator accurately and quickly the amount of material yet to be removed. The universal junior indicator is particularly valuable in setup work, as the dial can always be maintained in an easily visible position. The rotating friction sleeve, which carries the ball contact point with it, can be rotated to indicate any position, while the ball contact point, which is held by friction, can be moved to any angle. Here is the last word indicator being used to center work on a jig borer. This type of indicator can be mounted by means of a clamp attachment on a universal shank. This newly designed swivel shank provides an adaptable, easily adjusted indicator setup. It is easily screwed into the threaded hole in the head of the body of all last word indicators. The universal dial test indicator is extremely sensitive and adaptable to operation at almost any angle. The contact movement is perpendicular to the face so that the indicator can be easily read. From the simple steel rule to the precision micrometer caliper and dial indicator, as individual tools or in sets, Starrett tools are preferred by skilled mechanics with whom accurate workmanship is a matter of pride as well as a means of livelihood. Years of experience in precision tool manufacture is now making possible the production of hacksaws, band knives, and flat stock of superior quality. In the words of Thomas Carlyle, man is a tool-using animal. Weak in himself and of small stature, he stands on a basis of some half-square foot, has to straddle out his legs lest the very wind supplant him. Nevertheless, he can use tools, can devise tools. With these, the granite mountains melt into light dust before him. Seas are his smooth highways, winds and fire his unwearying steed. Nowhere do you find him without tools. Without tools, he is nothing. With tools, he is all.